Hey, welcome to The Explainer. Ever stop and think about how your phone, your search engine, your smart speaker, how they actually get what you're saying? Today, we're diving deep into that very question. How on earth do we teach a computer to understand human language? For us, it's second nature, but for a machine, it's one of the trickiest puzzles out there.
All right, take a look at this headline, Iraqi head seeks arms. Let that one sink in for a second. Are we talking about a literal head that's, looking for some arms to attach, or are we talking about the leader of a country trying to buy weapons? To us, the ambiguity is kind of funny, right?
But here's the thing. For a computer, that ambiguity isn't funny at all. It's a massive problem. Our language is messy. It's packed with context and unspoken rules. So where do you even begin trying to teach a machine how to navigate this beautiful, chaotic system of ours?
To answer that, we first have to really get our heads around the challenge itself. So let's break down exactly what makes our language so incredibly tough for a machine to figure out.
Okay, let's dive into this. The whole field of science trying to crack this code is called natural language processing, or NLP for short. You can think of it as a part of AI that's focused on one thing, getting computers to make sense of the stuff we say and write.
The whole journey starts by turning our words into something a computer can actually work with: data. Before a machine can understand anything, it first has to learn how to count. It's the most basic building block.
So, a computer gets fed this classic first line from Moby Dick. Now, it doesn't see a famous character introducing himself. Not yet. At this very first level, it just sees a raw string of characters. A C, then an A, an L, another L, a space, and so on. That's it. It's just pure, meaningless data to start with.
So, to make any sense of that long jumble of letters, the computer has to do a super important first step called tokenization. It just breaks that raw text down into a list of its parts, the words, and even the punctuation. Each one of those little pieces is now called a token. Now, what's really interesting about this slide is what happens next. Once we have tokens, we can actually start to measure language. So for example, in the book of Genesis, you've got almost 45,000 total word tokens. But the number of unique words, the types, is way smaller, under 3,000. This difference between all the words used and the unique vocabulary is a really key concept for NLP.
Okay, so the computer can count words. Big deal, right? That's not real understanding. The next huge leap is to teach it grammar. How do words actually work together in a sentence? This is where things get really interesting.
Just look at the word wind. How in the world is a computer supposed to know that in one sentence it's a verb, an action, but in the other sentence it's a noun, a thing? It's the exact same 4 letters, but they have totally different jobs.
Well, the solution is this really clever technique called part-of-speech tagging, or just POS tagging. A program goes through the sentence and labels every single token with its grammatical category. Is it a noun, a verb, an adjective? It's kind of like we're giving the computer a pair of grammar goggles. And this is what that sentence looks like to the machine after it's been tagged. See? Every word, every token is now paired up with a little tag that tells the computer it's part of speech. The is a DT for determiner, county and jury are N for noun, and said gets tagged as VBD, a past tense verb. This extra layer of info is absolutely crucial for understanding how a sentence is built. Okay, let's build on that. The computer can now see the job of each individual word. That's a huge step forward. But sentences aren't just a random string of tagged words. To get the bigger picture, the machine has to learn how these words group together into phrases that actually mean something.
I mean, just take this phrase here. We don't read the Fulton County Grand Jury as 5 separate words, right? No, we see it as a single unit, a single concept. It's one entity. The computer has to learn to see that too.
So the way it does this is a process called chunking. And it's pretty much what it sounds like. The computer takes the stream of tagged words and groups them, or chunks them, into meaningful phrases. So it learns to see that whole group of words as one single noun phrase. It's not just seeing words anymore. It's starting to see the real building blocks of a sentence. So the final step in all this grammar work is called parsing. This is where the computer takes all of those chunks and phrases and figures out exactly how they all connect together to form a complete structured tree. You can think of parsing as building the full grammatical skeleton of the sentence.
And what you get is a parse tree like this one, which brilliantly illustrates the whole structure. You can see the whole sentence S at the top. It branches out into its main parts, a noun phrase NP, in this case just Alice, and a verb phrase VP, which is chase the rabbit. Then that verb phrase breaks down even more. This tree is the complete blueprint of the sentence's grammar.
So, we've gone all the way from raw letters to a full grammatical map of a sentence. But what's the point of all this work? What's the payoff? What can a computer actually do with this kind of understanding?
Well, this whole pipeline we've been talking about, it powers technology you probably use every single day. It's how your email knows what's spam, how a website can analyze if a product review is positive or negative. And it's the core logic behind machine translation and those digital assistants that answer our questions.
For instance, if you're building a movie review classifier, the system learns that a word like outstanding is a really strong sign of a positive review. But then it also learns that words like wasted, or even an actor's name like Siegel, apparently, can be strong predictors of a negative review. It's all about learning to connect words to outcomes.
So yeah, all this complex work, the tokenizing, the tagging, the parsing, it's the hidden engine that's running behind the scenes every single time you search for something online, ask your phone about the weather, or find that one annoying email has landed perfectly in your spam folder. It's truly a cornerstone of our digital lives.
So, the crucial point to take away from all this is that it's a layered process, a pipeline. You have to start with the raw text, break it into tokens, give those tokens grammar tags, group them into chunks, and then build the full sentence structure. Only after all of those steps can a computer even begin to get at the meaning. Each layer depends on the one before it.
And that leads us to the biggest final question of all. We've seen how we can teach a machine the rules and the structure of language. But what about everything else? The nuance, the sarcasm, the poetry, the subtext, the creativity. Can we ever truly teach a machine to understand the full, amazing richness of human language? Well, that remains one of the greatest challenges ahead. Thanks for joining me on The Explainer.